Today we're going to continue our discussion around using proof with a focus of angle proofs. Your objective students will be able to use proven facts or theorems to write angle proofs. There's a couple vocabulary words that we really need to orient ourselves around. One, a proof is a mathematical statement, detailed explanation of how a statement follows logically from one statement already accepted as true. And then a theorem is a mathematical statement with a proof. And so the combination of these two things is essentially the more recent lessons that you guys have been covering in geometry. So you may want to pause the video to write down each of the definitions because you're going to utilize them later on. And then what's really nice about theorems and proofs is once a theorem has been proven, it can be added to the list of known facts used in proofs of other theorems, because theorems are statements that have been proven. For example, lesson 9, which is what we did on Monday, vertical angles are of equal measure. We can now use that regularly when we're justifying any of our statements. We also know that if a transversal intersects two parallel lines, alternate interior angles are of equal measure. And you're going to want to kind of begin a list of these theorems so that you use the same language each time. The consistency just allows you to be better at describing and proving or justifying each part that you're stating. So as I look at this, and they want us to use these theorems or properties, it says in the diagram to the right you are given that line segment AB is parallel to line segment CD. So essentially this line segment, we'll put the symbol in there, is parallel to that line segment. And then we want to use our knowledge of congruent vertical angles or alternate interior angles to prove that X equals W. So angle X congruent to angle W. You may want to highlight. Once you've identified what you're trying to prove, it's very helpful to go in and add some color so that it stands out to you. Okay, and essentially what they're forcing you to do is use the statements. Normal proof won't indicate to you the exact steps that you need to follow. This is just getting you used to how you could practice. And I'm going to introduce you guys to what we call a two-column proof. So there are going to be statements. I draw my column line, and then there are going to be reasons. And so each statement, sometimes you'll see people number them, sometimes you won't. You can do this in paragraph form, but this is normally the beginning part of how a lot of proof is taught. So line segment AB is parallel to CD. That is a given statement. But as we've done throughout this course, we kind of know that once we have parallel lines, there's a lot of nice results. Also, anytime there are intersecting lines, we know intersecting lines form vertical angles. And then Monday we proved that vertical angles are equal, so we can combine that. But I go back and I want to make sure X is equal to W. So X is equal to W. What could I start with? Well, if I think about things in terms of vertical angles, I could say that W is congruent to Z, and then Z is an alternate interior angle to X. And so what I'm doing is sort of creating a plan. Now, this is not the only way to do it, but it's just one plan that you can look at. So I know that X is congruent to Z, or the measurements are equal, and I know that if parallel lines are cut by a transversal alternate interior angles are equal, in measure. Okay, so that's the reason why I'm able to claim that the measure of angle x is equal to the measure of angle z. I can also claim measure of angle z equals the measure of angle w, vertical angles have equal measure. And these are two theorems that we have proven in the past couple days. And then finally, measure of angle x is equal to the measure of angle w. And to use one of the new words that you guys have seen in yesterday's properties video, we're going to use a transitive property. You could also use substitution. Substitution is a little bit more widespread. The transitive property is set up because you can kind of see that x is equal to z, then z is equal to w, therefore x has got to be equal to w. It's this kind of zigzag pattern. And what we've really ultimately proven now, and that we can use long term, is that corresponding angles are congruent or equal in measure when lines are parallel. So your conclusion now we can use this going forward. If parallel lines are cut by transversal, corresponding angles are equal in measure. So there was an actual reason why you went through this proof, and now you're able to add this to your bank of theorems. And so here are the three that you can use. You now have available to the following facts: vertical angles are equal in measure, alternate interior angles are equal in measure, and corresponding angles are equal in measure. You want to write those down so that you can use them each time that they come up within a proof. Again, go back, rewind if you need to rewatch. Look at the way reasons were given for each step. Make sure you're familiar with the vocabulary words proof and theorem, and make sure you're familiar with each of the three theorems that you have proven already so that you can use them in the future. Thank you.